All right, let's go ahead and get started on lesson 3.5, proving lines parallel. And we will kind of make use of our notes here, but hopefully you've already done the vocab. Again, that's something you're supposed to do right before you watch the video, and then we're going to jump right into this. So if you have any questions, make sure you come in and talk to me before or after school, or at least bring them to talk about in class so we can make sure we understand these things a little bit better. We will be looking at actually proving that lines are parallel in this lesson. So we will do a little bit of proof. Don't panic. It's going to be fine. You'll understand it. Basically, lesson 3.5 takes what we did in lesson 3.2 and just flips it around. We are taking literally the converse of these statements. And so I want to remind you of what the word converse means back from chapter 2. The converse of an if-then statement. Okay? If our conditional if blank then blank was originally in this form, if P then Q, the converse of that statement flips it around to if Q then P. And so in lesson 3.2, we understood that if we had lines that were parallel, then we had congruent angles or supplementary angles. All right? Corresponding alternate interior angles, alternate exterior angles were congruent, and then consecutive interior angles were supplementary if we knew that lines were parallel to start with. So that's what we started with in lesson 3.2. In lesson 3.5, we are going to flip that around. We are going to start with congruent angles or supplementary angles, and then conclude with parallel lines. Okay? So we're just flipping that information around. So that's what lesson 3.5 is about. We are verifying or proving that lines are in fact parallel. So let's talk about our objectives. In the past, we've found slopes of lines, used them to identify parallel perpendicular lines. Now we're going to recognize angle pairs to recognize parallel lines, and then also use that to prove that two lines are parallel. So we're going to start with this first postulate, and notice that it is the converse of the corresponding angles postulate. It says if corresponding angles are congruent, so if we know that part first, then we can conclude that lines are parallel. It's just flipping around the corresponding angles postulate. And we also have the parallel postulate. That states if we're given a line and a point that's not on that line, there's only one parallel line through that point. Okay, so again, I'm going to highlight the given information for you in this example since it's not color-coded. If we are given that line and that point, okay, that's our given information, then we can conclude this line is parallel to that line. Okay, there's only one of those lines parallel. And then we also have these other theorems that come from our alternate interior angles theorem, consecutive interior angles theorem, alternate exterior angles theorem, and then we also have this perpendicular transversal converse that we'll look at. Okay, first of all, again, we're just taking the theorems from lesson 3.2 and flipping them around. So if we know that alternate exterior angles are congruent, then we conclude that two lines are parallel. If we know that consecutive interior angles are supplementary, then we conclude the lines are parallel. If we know that alternate interior angles are congruent, then we conclude, again, that lines are parallel. If we know that two lines are perpendicular to the same line, then we can also use that to prove that lines are parallel. So you'll notice that all of these end in the same way as did our corresponding angles converse. And that says that lines are parallel. That's what we're concluding. That's our final conclusion of our statements. And so let's put that into practice. So here's what we're going to do. Example 1, we are given some information. So we're going to start by understanding that given information and marking it on the graph or the diagram. So we're going to start with that given information that angle 1 is congruent to angle 3. So we're going to mark those congruent. Angle 1 is congruent to angle 3. Then we're going to look at what we know about those angles. They ask the question, is it possible to prove that the lines are parallel? If so, using the postulate or theorem that justifies our answer. So here's what I want us to do first. We notice that these angles are congruent, and notice what kind of angles they are. We're looking at angles or lines A and B, and the transversal is this segment. Call it T if you want. They are both on the same side of the transversal, and they are both below their respective lines A and B, so these are corresponding angles. And since these corresponding angles are congruent, the lines have to be parallel by the corresponding angles converse. Or basically, we're using this logic. Since corresponding angles are congruent, then we have parallel lines. Okay? For part B of example 1, we are given a little bit of different information. We are told the measure of angle 1 is 103 degrees, and the measure of angle 4 is 100 degrees. So let's look at those. Measure of angle 1 is 103 degrees, and measure of angle 4 is 100 degrees. Now, these are along lines C and A with a transversal, and they would be alternate interior angles. Okay, their measures are not equal. So they're not congruent angles. Since alternate interior angles are not congruent, I cannot say that they are parallel. Okay, if they were congruent, then they could be parallel by the alternate interior angles converse. All right. So we're going to use some of these same ideas in example 2. This is a standardized test practice. This is a type of problem you might see on a state assessment or maybe even an ACT problem. And so we're going to practice how we would do that. And I'm going to walk you through an explanation of how to go through these kinds of problems rather than just do the problem for you and hope you catch it. So there's going to be some things you need to read, and I will kind of point out important things to write down though. So here's our problem. They want you to find the measure of angle ZYN. And so I'm going to highlight that for you. Find the measure of angle ZYN. So we're going to find that. So I need to know what X is to find an actual measure so that these end up being parallel lines. Well, in order for these to be parallel lines, the information given uses this angle up here. And those would be alternate exterior angles. In order for these to be parallel, alternate exterior angles have to be shown to be congruent. So if I can set these equal to each other, find what X is, plug that back in, these would end up being parallel. And so that was a brief description. I'm going to give you a little more detailed description here. Okay, we're still looking for that angle measure so that they are in fact parallel lines. So from this figure, we know this information. And so these are important to write down. And we're asked to find this. Okay, this is just important information. If you don't want to write those things down, you don't have to yet. We're just reading the test problem to find that out, stating the known information, looking for what we don't know. Then we're going to solve the test item. We're going to put this into practice. We know that they're alternate exterior angles. For line PQ to be parallel to line MN, the alternate exterior angles must be congruent. That is important. Because they're alternate exterior angles, in order for these to be parallel, they should be congruent. Not supplementary, congruent. They're both obtuse angles from the look of it. So I can start with this. That's kind of our starting point. We're going to start by this, but we can even substitute right into that. and solve for x. Substitute, solve for x. That's kind of our idea here. So we're going to start by writing this equation. Okay, and if you want to justify each step, you can do so. All right, then the next step to solve for x is to subtract 7x from both sides, and then eventually add 25 to both sides. So 4x minus 25 equals 35, add 25 again. We get 4x equals 60, divide by 4, and x is 15. So this is the work that you would probably do on your paper. Okay, starting really right here, but this is kind of an explanation of how we get to that equation. And so if x is 15, then these would be parallel lines, but we need to find the angle measure. So what we're going to do is plug back in. And this is where we're going to do some work. We want the measure of angle ZYN. So we're going to plug 15 in for x into this expression. 7 times 15 plus 35, and then do that calculation. 7 times 15 is 105, and then add your 35 and you get 140 degrees for the measure of angle ZYN, and that would make them parallel lines. Alright, and here is our only proof we're actually going to do in the notes, and so I'm going to walk you through how to do this. It's just 4 simple steps. We are going to start with our known information and work towards what we're trying to prove using statements and reasons. So I'm going to help you kind of walk through this. Alright, excuse me. We're going to start with our parallel lines given to us. I'm going to go ahead and mark those first. Parallel lines here and here. We know that for a given fact. Okay, we're trying to prove that P and R are parallel. Alright, now we also know that angle 1 is congruent to angle 3. Now those are not along the same transversal, so we cannot use alternate exterior angles to just say that, and that's why they give me that information. So we're going to start with putting all of our given information down. L is parallel to M and angle 1 is congruent to angle 3, that's given. And then we want to eventually make the connection between lines P and R, which is why they've marked angle 2. Now if I could say that angle 2 is congruent to angle 3, they would share one transversal, so these lines could be parallel if the alternate exterior angles are in fact congruent. Well, because these lines are parallel, 1 and 2 are congruent because they're corresponding angles. So that's the next part. Angle 1 is congruent to angle 2. And there's 2 ways you can put this reason. We know that this is called the corresponding angles postulate, and this is one of your vocab terms, but you may not remember the difference between the corresponding angles postulate from lesson 3.2 and the corresponding angles converse from this lesson. And so here's all I want you to really focus on. All right? In this case, we made this conclusion about angles 1 and 2 because we first knew L was parallel to M. We started with parallel lines and drew the conclusion that corresponding angles are congruent. So we can write our reason like this. Parallel lines led us to the fact that corresponding angles are congruent. And so we can just write our reason that way instead of trying to remember a proper name, a title. We started with parallel lines, and then we got to the conclusion that corresponding angles were congruent. Now, if 1 is congruent to 2, we also know 1 is congruent to 3. Now, we could line these up and use our transitive property of congruence, POC, not E, we're not talking about equals, these are congruent signs. We can use our transitive property to say that angle 2 is congruent to angle 3 also. So all 3 of these would be the same. And now 2 and 3, like I said a little bit ago, are alternate exterior angles, so that means that these lines do have to be parallel. So we can say this line P is parallel to line R, and once again we're going to kind of take an easier approach to writing our reason. We know that we have alternate exterior angles that are congruent. That is stated first. So we have alternate exterior angles that are congruent, and that leads me to the conclusion that we have parallel lines. So this is actually one of the converse theorems that we learned today. But you can write it this way, and it's a lot easier to make sense of.